Hello and welcome to Sanford Uncut, a podcast for developers about building great products. Today I'm excited to welcome Keith Smiley. Keith, thank you so much for joining us.
Thanks for having me.
Yeah, please just go ahead and introduce yourself.
Yeah, my name's Keith Smiley. I'm a principal engineer at Lyft. I work mostly on developer infrastructure there, and I guess that's what we're going to talk about a little bit today.
Yeah, great. Can you maybe give us a bit of a background? How did you end up doing what you're doing right now?
Yeah, definitely. So, when I was in college, I got involved in the CocoaPods project, which mobile folks may know is a dependency manager for iOS, similar to NPM and Ruby gems, depending on what language you're using. And through that, I guess I made a lot of friends in the iOS community and also, got some great experience kind of like seeing what was out there. And so after college, I jumped straight into an iOS consulting job and worked there for a little while before moving to Lyft. And I've been at Lyft for almost 7 years now, mostly working on infrastructure during that time.
Great. Yeah, you mentioned that one of the main things that you're working on is building infrastructure for your iOS teams and that you're using Bazel. A lot of people are talking about Bazel, also monorepo. Some brave and jumping into the deep water straight away. Other cautious and being kind of late adopters, to say. Can you give us a bit of a history? How did it work in Lyft and how we ended up using like monorepo and Bazel and so on?
Yeah, definitely. So at Lyft for a long time, we only had like one app. We had this, combined rider and driver app. And, we had a relatively small iOS team, although at the time, like even, 7 or whatever we had seemed kind of large for mobile teams. But then we kind of started to grow. We ended up splitting those apps because, the experiences diverged a lot and the people working on them were very different. And there were a lot of technical reasons we did that. And then our team kind of exploded around that time. And so we went from 15 or 20 iOS engineers to like 60 over the course of a few months. And, around that time, we knew that we were starting to hit some like difficult technical challenges. And for folks who've worked specifically in iOS, they'll know, the tools don't particularly offer a lot of flexibility. So when you want to kind of go outside of the golden path, it can be really difficult. So we started looking around at some alternatives. And Bazel was looking pretty promising at the time. And so, we had a lot of incremental steps along the way. You mentioned the monorepo thing. At some point we had our apps in different repos, and then we had like some shared repos for dependencies. And anybody who's worked with Git submodules or managing a setup like that knows that that provides some challenges. And so a monorepo kind of felt natural at that point, especially because we were sharing so much code between all of the apps. And that kind of like reduced the operational burden of that a lot, but also opened the door to Bazel. For a lot of reasons, Bazel has some, preferences that you're working in a monorepo as opposed to many different repos. So that definitely made that a little bit easier. But either way, for us, I think that like the developer experience of having monorepo is much nicer. So we started experimenting with Bazel, and that ended up working really well for us and still is today. We got a lot of the kind of benefits that you may hear about if you just hear the kind of headlines for Bazel, like being able to remotely cache build artifacts so that if, I build it on my machine and then you go to build it on your machine, you can just download what I built instead of having to rebuild it yourself, which for us meant a clean build of our, rider app instead of taking 15 minutes would take 2 because you could just download everything, which was, a huge improvement for developer experience. And since then, since we moved in general, our, code has continued to grow. And that's pretty much worked the same way it did since then. So it's been a really great tool to allow us to like continue scaling our code base and team and number of apps and everything. So I feel like we've had one of the kind of ideal experiences with Bazel so far.
Great. And you mentioned that it was like a couple of years ago that you actually embraced Bazel. Do you remember how the actual introduction of Bazel worked with the whole team? Because it usually doesn't work that way, that we say, okay, on Friday this week, we are going to start using Bazel. And that thing that you worked on, you don't work that way anymore. That kind of hard switch is completely unrealistic, especially with the big teams. So how did you navigate those waters of like introducing people to that and maybe running everything in parallel first or how that worked?
Yeah, definitely. So there were a lot of like incremental steps in that migration for us. So, one thing especially about iOS in that community is that, most folks are using the exact same IDE. Everyone uses Xcode. It comes from Apple. They just kind of expect some basic functionality in that to work, right? Like they hit whatever keyboard shortcut to run on their device and all of that stuff. So, we knew from the outset that we had to mirror that experience as much as possible, but that also kind of gave us the opportunity to like make changes without folks particularly noticing. So, we had a few different steps. One was we made folks define kind of like their modules, which is kind of the unit of code separation that we were using, in some sort of configuration file that was like text-based, and we ended up using that to generate an Xcode project even before Bazel. And that was super useful just because folks could actually review configuration changes as opposed to having some kind of opaque file format, which is kind of the default in the iOS community if you configure everything within Xcode. So that already felt pretty natural for folks, and that was a good analogy to Bazel's kind of build files. And then we ended up actually kind of like replacing those with build files. So there was a bit of a change for developers there, but realistically, they're mostly just adding one line here or there to add different dependencies. So that wasn't a huge change. And then we, started using that to build our project on CI. So still kind of transparent to developers, but we started getting some of the benefits immediately for ourselves on CI because we could start using those caching features and all of that. And then we kind of incrementally swapped the kind of local developer experience over, but still maintaining that kind of normal Xcode experience. So unless you know where to look, you can't particularly tell that it's Bazel. There are a few places where it differs significantly, but that was a really great path for us because it was much more approachable for folks who were joining who've never heard of Bazel.
We've just released the CI/CD for monorepos ebook. It's for software engineers who are evaluating or want to optimize the monorepo way of software development. You'll learn how to build a monorepo-first CI/CD pipeline and have a functional microservice application built, tested, and deployed from a monorepo. Check it out on our website, semaphoreci.com/resources/monorepo-CICD.
And from that day-to-day operational standpoint, I assume that developers over time became comfortable and they are actually maintaining their own Bazel build configurations for their own modules, or there is a maintainer of the whole build configuration who kind of steps in at some point.
Yeah, so there's a few pieces, and this is definitely one of the cool features, I think, from Bazel. So there's like the end build files that folks actually define their kind of modules in, and those are completely maintained by developers, but they're also very simple. It's like, I have this module, it has these dependencies. I have this test target, it has these dependencies. That's pretty much it. And then there's kind of the layer that we have on top of Bazel. Bazel allows you to define what they call macros. You can also define like full on rules. There's some kind of like subtle technical differences between those two things, but either way, the benefit is that you don't have to use exactly what Bazel provides out of the box. And if you want to, you can abstract it such that the interface that your developers use is more specific to you. So we put in some work to do that, to make it more ergonomic for our developers and kind of hide some of the technical complexities of Bazel or just the differences there. So the tooling team who maintains like CI and all build tooling stuff maintains those, but those mostly don't have to change. I mean, maybe when there's new Bazel versions or new features in Xcode or something, we have to change those, but developers pretty much don't have to think about those, and that works really well for us. I know some folks prefer not to abstract that kind of stuff, and there are benefits in that, like, you switch between projects and it can work the exact same way. But in our case, with this kind of mobile monorepo where there's like one central team that owns all the build tooling, I think that makes it easier for developers, and that team can create like a consistent development environment for everybody, and also make sure people don't accidentally shoot themselves in the foot with some feature that may not work on iOS the way that Bazel intends.
Maybe to kind of rewind a little bit for the folks who don't know maybe what Bazel is, and also maybe some tips on approaching Bazel and how you got introduced to it and how your learning path looked.
Yeah, totally. So I guess to start with what Bazel is, which maybe we should have dove into first. It kind of depends on what community you work in for the best analogy to Bazel. If you're familiar with C++, maybe you used CMake. It's a nice replacement or a alternative to that. If you're from the Java land and you used Maven or something, maybe you can use that as your analogy. But mainly Bazel is like a language agnostic build tool. So it knows how to take some source files and produce some output binary. And it just knows how to do that for a lot of different languages. And it mainly has the smarts to do a lot more than that because of the rules that it enforces. So what I mean by that is that one of Bazel's kind of top line goals is to be hermetic, meaning that with the same inputs, you'll always get the same outputs. And that gives you some guarantees, like the thing I mentioned earlier, which is if I build something on my machine and you go to build it on yours, as long as the inputs are the same, we know the outputs are the same. So we can just download it from the internet instead of spending your CPU and time building that. And that's a pretty hard thing to guarantee because you have to define the entire set of inputs, which, includes what version of the tools do you have on your computer and what environment variables have you set that could affect this and all of that kind of stuff. But once you kind of work within that sandbox, it's very nice and you can get some nice benefits like that remote caching piece from that. So that's kind of like the core of Bazel. And then there's this kind of separate concept in Bazel called rules. And they define against some public API that Bazel provides how to build every different language. So for example, there's rules Go that knows how to compile Go code. And there's rules Apple, which knows how to package iOS apps and things like that. And one nice part about that architecture is that those rules are entirely separate from Bazel. You can create them yourselves. You can maintain them yourselves. And this is nice for Google because they don't have to know how to compile every single language in the world or maintain all of that. But it's also nice for users because it gives you a lot of flexibility to make things work the way that you need them to. Maybe for your internal stuff, you can create your own rules and things like that. So that's kind of like a high level look at what Bazel is. I think getting into it is an interesting question for sure. So there's a lot of, resources out there, in the Bazel documentation and from Bazel conferences that have happened a few times called BazelCon that Google hosts. There's a lot of kind of talks about how folks migrated and how they got into it. So there's a lot of great tips in there that folks can look at. I think that if you're familiar with some other types of build systems, Bazel should be pretty approachable. It's just that, it might be a little bit more strict than you're used to try to enforce some of those hermeticity guarantees. But I think once you get into that, it's quite nice. I think the build configuration language is pretty approachable. It's like this subset of Python, which is very nice to use. And it has a lot of nice features to allow you to kind of like introspect what's going on. So one thing that I often find myself trying to do is, figure out, why does this target end up depending on all of these other things? And Bazel has this really powerful query language where you can kind of do, SQL type queries against your build graph, which can give you some really nice insight into what's happening. So once you kind of get used to some of these tools, I think that it actually is a very usable build tool, especially compared to some of the alternatives out there.
Mm-hmm. And you mentioned depends on the language and the background. And from generally hanging up with folks who are using Bazel on maybe different projects and so on, how would you define some sweet spot when it makes sense for teams to maybe start looking into Bazel? And then, of course, eventually potentially adopting it.
Yeah, this is definitely one of the hardest things to put a specific time frame on. I think that especially when you go around and talk about how great Bazel is, you get a lot of people who are like, oh man, we, really want those benefits because our code base is really slow to build, but there's only two of us. Like, should we move to Bazel? And I definitely think that right now, while I do think Bazel's can be approachable, it can still require a bit of maintenance. And this depends a little bit on the communities and how fast, Bazel itself is changing with what you're trying to do. I think some, kind of communities are more stable than others, but we have definitely found that, maintaining the Bazel setup takes a decent amount of time. So I think you definitely have to have, at least one person who can dedicate most of their time to working on that, which is some bar for when you might want to adopt it. I guess the other thing is that, there are a lot of other options depending on your set of problems before you move to Bazel. I think Bazel is a pretty big hammer for this. And so in your community, like in your languages community, you probably have a lot of tools that you can use or a lot of tweaks you can make to the default tools to kind of help with some of the specific problems you see. And we did a bunch of that before we moved as well. And I think going down that path is definitely worth doing because of that kind of maintenance cost and everything. So yeah, I wish there was a more clear, like, this is when you should cut over. But, once you've exhausted those options and feel like you can take on that maintenance burden, that's, I guess, when it feels like it starts to be worth it to me.
Yeah. Well, that's I would say, reasonably precisely defined moment. And you mentioned a number of benefits that Bazel provides. Not having to rebuild the same stuff over and over, obviously huge one. In terms of testing, what can you say about that area?
I heard at some point someone from Google say that like Bazel isn't a build tool, it's a test tool. And it's an interesting way to think about it because testing has a different set of concerns, right? Like whether or not your tests are maybe written in the same language as your actual code because you have some sort of integration tests, or, what environment do you need to set up for your tests? There can be some serious complexities there that I do think Bazel makes way easier than any other build tools. So test rules look very similar to kind of build rules in Bazel. You can define a test, it can have some sources, dependencies, and all of that kind of stuff. Then Bazel can also, apply its smarts to only run those tests if something that is an input to them has changed, which is very nice because if you have hundreds of test bundles and you just say run all the tests, Bazel could end up running, literally nothing depending on, if those have been run before with the same configuration. But it also gives you a really nice way to kind of interop between languages for different types of tests. So one example is that for us, we have a lot of internal tools that are assist with the building of our apps. And those are all also built with Bazel and kind of run with Bazel and tested with Bazel. And so it's a very common pattern for us to have, some Python command line tool that has some Python unit tests, but then it also has some integration tests that maybe you kind of orchestrate with some tiny shell script that just runs the thing and verifies the output and that kind of stuff. And Bazel does a great job at kind of treating all of those things the same in a way that's very transparent. You can run any types of tests together. It does a really great job at that.
We've just released the CI/CD for monorepos ebook. It's for software engineers who are evaluating or want to optimize the monorepo way of software development. You'll learn how to build a monorepo-first CI/CD pipeline and have a functional microservice application built, tested, and deployed from a monorepo. Check it out on our website, semaphoreci.com/resources/monorepo-CICD.
And those build tools that you mentioned, I think it was clear that all the iOS code is in the same repository. So then I assume that all those helper bit tools that you mentioned that are maybe in Python and so on live in that same repository, right?
Yeah, that's how we do it. Technically, if we wanted to, we could pull those out. We haven't really talked about exactly how Bazel manages that, but, definitely you can use other repositories. We do that for, open source dependencies that we pull in, for example, or, dependencies we pull in through native package managers like PyPy for Python. So there are ways you can do that. And, if we really needed to, we could extract our tools into a separate repo and then kind of like vendor those through Bazel. It's just, been a little bit easier for us to have kind of like single commit changes the world kind of things with our monorepo. And also, since we have all of our iOS code in one repo, we don't technically really need those tools outside of the repo anyways, so that makes it a little bit easier. But Bazel does fully support that if you want to. It just can make things a little bit more cumbersome because, similar to Git submodules or other ways you might deal with this, you're going to have to do some like, reference bumping kind of overhead every time you want to, update your separate repo.
One of the things that you mentioned in our prep call is that you save a lot of essentially, CPU time, machine time, by not running everything, and that your iOS, not iOS, but Mac build cluster that you have in-house would need to be much bigger. Do you have a gut feeling? What's the difference between if you have been building everything all the time for the end developer's experience comparing to this dependency management that you have where you can decide what needs to be built and not?
Yeah, there's kind of two pieces to that. One is kind of the local developers, like how much are they rebuilding when they don't need to, or would they be rebuilding when they don't need to? And the other one is CI. I think for local developers, the, kind of prime use cases, like they're, pulling the main branch after finishing working on a feature. And that also includes potentially hundreds of other commits. And then they want to start working on a new feature. So they rebuild the app. And at that point, without Bazel, you'd end up pretty much doing a clean build every single time because there's just a lot of churn in the code with a lot of engineers. But instead, they can pretty much download everything and get going much faster. And then as they start changing stuff, of course, there may not be cached artifacts for what they're trying to build, but at least they kind of got off the ground there, not having to rebuild things that they didn't actually change. So I think in that case, that was the example I used earlier of like 2 minutes versus 15 minutes. So it's a pretty big order of magnitude. It definitely varies, per app and what they're building, if they're just building test targets or whatever. But yeah, then there's CI. So yeah, for iOS builds, we have to run CI on macOS. And so we have our own Mac Mini fleet that we manage, that we started managing kind of before there were too many cloud providers out there providing Macs. And one thing, about that is obviously we can't auto scale that. So we need to be very careful about the CPU time on those machines, especially in a monorepo where we build, 10 apps. Like if we have 100 machines, which is about what we have today, then 10 PRs theoretically would consume all of those if you were just building the apps, right? But then realistically, we also do a bunch of test jobs and a bunch of lint jobs and other things like that. So, it'd probably only take, I don't know, 3 PRs if you were running everything at the same time. And when you have, on the order of dozens of engineers, it's not uncommon to have, I don't know, I think we have over 1,000 PRs open right now or something. Not that they're all active, but you can definitely see how you could very quickly get to a point where CI is just constantly consumed. So yeah, we avoid that as much as we can by, using Bazel's kind of query that I mentioned before to only build and test the things that we know might have changed. And then even inside that, Bazel can even be smarter and decide, oh, well, I don't even need to build that part and the build can still be very fast. But we kind of avoid even the CI machine scheduling ahead of time. So that still saves us a lot of parallelism that we have on CI. And I think the way that we see it mostly today, I don't have solid stats on this off the top of my head, but most PRs only touch like one app in our project. So for sure, we're saving a lot of time there as opposed to if we were building all of the apps, because 1 versus 10 jobs or something. And that's kind of the same for the test targets. We have probably 1,500 or so different iOS test targets. And most people submit PRs that only change maybe 5 modules at some time. So you can run, 5 instead of 1,500. It's a really big order of magnitude for us. There are, of course, occasional like foundational changes that will trigger everything. And then that's totally fine. But most of the time, I would say, like the standard case of a feature developer working on a new feature, it's going to hit the best case here where you only rebuild a very small part of the project.
That's interesting. A question coming from someone who has zero hands-on experience with Bazel. Earlier, you mentioned that SQL-like language where you can query various information about your build. Does that mean that somewhere there is a kind of a database which is supporting Bazel, where you can query also data about all the previous builds and those kinds of things?
There is not. When you do a Bazel query, it kind of, as far as I understand how it works, it kind of queries against Bazel's current memory of like what the build graph looks like. So Bazel is kind of 2 pieces. There's a client and a server. Like the first time you run a client, it like forks a server, and then that server, lives for a while and it'll take your kind of build requests over time. And so one of the things that can make Bazel be fast is that it'll load all of your build files and like the entire build graph of whatever you're trying to interact with the first time it needs it, and then it'll keep that in memory. And then if you change a build file, maybe it'll invalidate that, but otherwise it'll kind of keep that around. So when you run a query, you're kind of running against that current in-memory version of that stuff. So it doesn't know about any previous builds in that case. I do know there's folks in the community who have built services to kind of keep some of that memory, because to kind of do smarter test avoidance. So, one problem you may have in the test avoidance kind of scheme that we do is that if you add a target, it's unclear what we need to rebuild potentially, because we only know that these files changed and that this target is new, but we don't know, well, what targets are technically affected by this. Maybe it's more clear in the deletion case, because say I delete a build target, and how do I query what that affected previously now that it's gone? And so some people do store that kind of previous build information so that they can do those kind of smarter things. And I think if you had monorepo with, say, your entire company instead of just one platform, you might actually need to do that, because rebuilding the entire world isn't feasible if you're talking about every line of code of your entire company. And it would be really nice if Bazel provided something like that. I know some other tools have provided that in the past, but today, at least, it's just the current state, and you have to kind of roll that yourself if you want to store previous states.
One of the things we usually face is that people have, let's say, 15, 20-minute build pipeline. And as you also said, at some point in the life of a company or a team, it quickly gets from, 10 or 20 developers to maybe 60 or, even 100. And during those periods, it's relatively easy to destroy kind of the productivity as, more code is coming in, all those tests needs to be maintained. Some tests are just getting longer. and so on and so on. Complexity increases. And at that point in time, kind of you have to start instrumenting everything, sorting by the, duration of various blocks, modules, how long it take to build, maybe even instrumenting on the level of a test, and then, seeing what's the problem in order to ensure that developer productivity, that, as you said, in your case, can be as low as 2 minutes, but let's say under 5, under 10, something reasonable. And people just, start wrapping pieces of their build pipeline into blogs that, do some kind of instrumentation, and then are submitting that to, either some Prometheus is getting the data, or InfluxDB, then charting it in Grafana, and so on. Can you maybe share some of your experiences in that area?
Yeah. So, I mean, as far as data collection, I think Bazel provides a lot of its internal data, and you can kind of use it however you want. So they have a lot of different types of logs you can dump. We pretty much dump all of these for different use cases. You can get a Chrome trace, for example, so that you can see how each step in the build, how much it took overall. And, you can see that broken down by core, and you can see that broken down by what's the bottleneck. So that can be a really nice bird's eye view to just start like, okay, the build's slow, where do we start? That's a really nice tool for that. And we use that when developers come to us and say, hey, this build was longer than I expected. Why? Then you can kind of get a little bit more granular with that too. Bazel dumps some sort of like JSON file that talks about every single action it did and how long it took and all of that stuff. So you can kind of parse that data out and use that however you want as well. So we use that to populate graphs in, Wavefront, Grafana, whatever, for, what targets take the longest to build, what tests are the flakiest, and all of that kind of stuff. So you can get a lot of really great information from that. The other cool thing that we're starting to see now in the community is Bazel has this feature, the feature that's tied to dumping that JSON log. You can also stream that directly to a web service, and then the web service can kind of do whatever it wants with that. So there are some startups in this space working kind of dashboards for that, which is really cool because you'll start a build, it'll print a URL and say, hey, if you want to see these test results somewhere else, you can go there. It's the same as what you'd see locally, but then it can also provide a bunch more data. So you can go to these dashboards and click through different tabs and kind of see all of this kind of information as well. And that's provided a really nice way for us to share, oh, hey, there's a slow CI run. How do you dig into this? You can start there and then try to dig in a little bit further. So it can provide a lot of really useful tools to kind of get that top level view, but then also drill down to try to figure out what specifically is the problem. And maybe you find some test targets you need to break up or something like that, or just, improve the test itself. And we've done that a ton.
Yeah, great. Yeah, as long as the bug level logs are there and some parsing, all the answers can be answered. You just keep bringing up questions. You mentioned flaky test. And over the years, I can't believe, how many conversations with, our customers we had about helping them, how they can minimize, flaky tests in their test suite. There are many different technologies, different kinds of tests, many moving pieces in some end-to-end tests. The network is, inherently unstable, and we have to fight with that. And a lot of people are just resorting to, okay, there is a flaky test, straight away we are opening a Jira, Trello, issue, ticket, and then someone is going to deal with that. Some people, build some automation to just populate, some tables somewhere in the database with potentially flaky tests and so on. How are you guys handling that? If I understood correctly, there is also something on maybe a first-class citizen of Bazel that can help with this?
Yeah, so Bazel has a few features for this that are pretty cool. So every type of test target, you can actually just set a Boolean like flaky true. And then every time you run it, Bazel will run it multiple times and only pass if it passes some percentage of those times. And there's some knobs you can change to how many attempts do you want to do and stuff like that. But that's a really nice way to just say, okay, this test is flaky, we know it. And then maybe that's when you also file your Jira or whatever, but you don't end up immediately disabling the test at least. And maybe you can still get some signal from it. Like if it starts failing 100% of the time, Bazel will mark that as failed. That's pretty nice. You can also kind of do that globally if you want, which for some types of tests, like UI tests, maybe where you have a lot of inherently potentially flaky things, or your end-to-end test example of networking and stuff like that, you can kind of set that and just say every single time you run this test, you can run them multiple times if you want to, try to reduce the flakiness. that always feels a little bit bad to do because you're just kind of accepting that things are going to be flaky and there's nothing you can do about it. But it is a very practical option, I guess. So for us, we do, some combination of those things and, disabling flaky tests. And we, use our stats that we get on that to kind of like look at ones that are kind of consistently flaky and then actually try to trace those down. So we do some sort of that filtering as opposed to, filing a JIRA every single time we see it. I think there's something that's kind of unique about the iOS or mobile tests in general where, you have to run the tests through some sort of host environment. So for iOS, we run them through the iOS simulator, which introduces a whole new layer of flakiness that's very troublesome. And you can have the same problem. I mean, if you're running on devices or something, like either way, we have some separate component there. So I think probably a lot of our tests are flakier than we'd like, but those approaches kind of combined work for us pretty well.
Yeah. As you said, there are anti-patterns that we all do in order to just, be practical and survive the day and, keep pushing forward. But yeah, reruns practical, but can be poisonous if you rely on them too much. Have you seen maybe any major issues with that of being, abused? And then someone has to kind of step in and say, okay, let's raise the bar and lower that number of, reruns or something like that.
Yeah, I think we've had the classic case where it's actually flaky in the passing way, where, you realize your flaky test isn't just flaky failing, like it shouldn't ever be passing. And that's the kind of scariest reason to have auto reruns, right? So we've definitely had that case before. So we do try to stay on top of it. But yeah, obviously on a large team, that can be, difficult to track everyone down and get folks to prioritize it and all of those kind of, more human problems. And especially you don't want to particularly block things during that time. So we do try to get folks to track that down and, not have disabled tests that we've disabled due to flakiness and all of that. But, no matter what, that's going to kind of be asynchronous. So these other knobs help us in the meantime to make sure that no one else is affected by their tests flakiness. But yeah, I guess I'd say that that's the worst case is when someone actually finally goes to investigate it and they realize, ooh, my logic was wrong the whole time. And yeah, that's always a bummer.
Yeah, and the commit was 2 years ago.
Yeah.
Yeah, amazing. Thanks for sharing all these insights. I think it will be super valuable for people, who are going to get to the size of your team and the complexity, definitely, and then would be able to use these experiences to help their teams stay fast. Thank you again.
Yeah, thanks for having me.